Hi, I'm Kenton Shepard. We're here today with Dave Emmitt of Go Tankless, a division of Direct Drive Services. Dave, can you tell us a little bit about what you do?
Yes, Kenton. We've been in the installation of tankless, energy-efficient water heating, domestic and hydronic systems for about the past 17 years. We're one of the initial installers of some of these tankless systems here in Colorado. And what we do is integrate tankless systems with existing heating systems as well as for domestic hot water purposes.
Mm-hmm. Can you tell us what we're looking at here?
This is a tankless water heater. This is a manufacturer is Rinnai. They're a Japanese company. There are tankless water heaters that are manufactured in all parts of the world right now. Some of the best units that we're finding in the field are from Japan. This particular unit is an outdoor unit. As we can see, there's a vent right here. And this unit's designed to go outside. A lot of people find different tankless water heaters outdoors, being installed outdoors. There are only a few that can actually be installed outdoors. Rinnai is one of them here in Colorado because of the problems that we have with freezing.
Will other manufacturers' heaters look pretty similar to this if they're also for outside?
Sure. I mean, all the outdoor units will have a slit like this, which is the vent. Mm-hmm. And if you see this on an indoor unit, we got problems because obviously there's exhaust gas coming out here, and that's not something you want to be breathing.
What can inspectors be looking for when they come into a home or come to the back of a home and see one of these?
Yes, on an outdoor unit, the things really to look for are whether or not the pipes are protected, and there's no piping on here, but on an outdoor install you'd have piping coming off the bottom and gas piping over here. This piping needs to be protected from freezing, and there should be some heat tape wrapped around the pipes, and there should be some insulation on the pipes. There should be a cover box around this that actually covers the pipes and protects them from freezing and from the wind chill factors.
Or is that box something inspectors can typically open easily to take a look inside?
Usually there are just a couple of screws at the bottom of the box and pull the plate off and you can look inside. The other thing we recommend, and most of the manufacturers recommend, is a battery backup, so that in the case of a power outage, the unit has a way to protect itself from freezing.
So in cold climates, the insulation alone really isn't enough to keep the pipes from freezing.
Right, exactly. So you have to be conscious of that. Now, on an indoor unit, we typically have different types of vent systems, but this is one that Rinnai uses, which is a concentric vent. The concentric vent has a sealed combustion intake and an aluminum exhaust. Most of the tankless water heating systems that are available out there are sealed combustion, and there are several reasons for the sealed combustion. One, we don't really want to be burning indoor air because there's a much higher BTU consumption of a tankless water heater potentially than a water tank. The typical water tank is 34 to 40,000 BTUs. And this unit is 180,000 BTUs, and they go up to 300,000 BTUs in their energy consumption.
So you'd be taking oxygen from inside the house if it used combustion air from inside the house?
Correct, and there are units that do that, but one of the things that inspectors need to be careful about when they're looking at these units is if it is an indoor unit, and it is not a sealed combustion unit, does it have adequate ventilation? Does it have adequate combustion air? Because, again, if you have a tight house, and we see this a lot these days, in a tight house, if this unit is using considerably more oxygen inside the house than what a standard water tank would be using, we could have problems with indoor air quality.
Right. Is there anything more specific about outdoor tankless water heaters that we should know about?
Outdoor units are considerably easier to get right than an indoor unit because you don't have the venting issues with the outdoor units. And basically it's a matter of making sure that the gas piping is properly sized, which, as we just talked about, with a tankless water heater we could have 5 to 6 times the amount of BTUs being consumed if all of the fixtures in the house are open. For example, if someone's taking multiple showers at the same time, the unit could be burning considerably more BTUs. So gas piping is really the second issue. And we can run into that as an issue on both outdoor and indoor units, yes.
About terminology, what's the difference between a tankless water heater and a tankless boiler or a wall-hung boiler?
Well, that's a really good question. I mean, yes. Tankless boiler is really designed to be used for hydronics. Okay? And what I mean by that is a tankless boiler usually has a heat exchanger that's pretty resilient, and it's usually designed to be operated at 180 to 210 degrees.
Which would be a higher temperature than just domestic hot water.
Hydronic systems typically, and especially in the older homes, are designed to run at higher water temperatures. Some of the older homes that we go into that have cast iron radiators, you know, the big old, that were like we saw in our schools, we used to sit on to keep warm in the wintertime, right? Those typically need that 180 to 200 degrees of temperature to really have any recovery and really heat those old drafty houses, right? So though we have done it, we have hooked up tankless water heaters to those systems, you've got to be careful about it, and you've got to make sure that you do have enough radiation in that house to be able to heat it with the lower water temperatures at which these are designed to run.
And by hydronic, just so we're sure, you mean space heating rather than domestic hot water?
Domestic hot water versus hydronic, which is space heating. That's correct.
Typically either baseboard hot water or in-floor radiant heating.
Radiators or baseboards or convectors. Any time that water is being used as a source of space heat, that would be hydronics.
Is there anything more that we can talk about as far as the outside version of the Rinnai we're looking at?
I don't think so. I think probably the best thing to do now would be to open this thing up and take a look inside. Now, on the interior parts of this unit, other than the venting that we talked about, the vent system, there really is not a lot of difference between the indoor and outdoor units, because we are taking air in and we're pushing it out. We basically have two different places where that's happening, intake and exhaust. And both of them are happening here, just like this, where we have exhaust and intake. Okay, so it's a similar situation, but you're just using it with an outdoor sealed-up unit.
Can you sort of take us through this, starting with where the fuel goes in and how it goes from there?
Okay, yeah. Gas valve is this assembly right here. And of course, here's your gas line coming in. This is the incoming water, and this is the output. And what happens, this gas valve is always idle, no pilot, no nothing, until water is introduced into the system or until there is flow. So the gas valve is basically integrated with everything else. This little item right here is called a flow rater or flow servo. As soon as that flow servo detects water going across it, it spins a little wheel. Most tankless water heaters work that way, not all of them. Some of the older Bosch units actually, or Takagi units, use a little float instead. So as the water comes in, it's more of a mechanical system. This is a completely computerized system. So as you can see, this is a computer board, dip switches. Behind here is the main board. So this is a very sophisticated appliance that sends a signal as soon as water is introduced. The signal is sent to the board, and that signal is sent out to the gas valve. Now, the thing that sets, you talked about wall-hung boilers and tankless boilers. One of the things that sets a tankless domestic water heater like this Rinnai apart from a lot of the tankless boilers and other water tanks and things like that is this is what's called a fully modulating burner system. This gas valve and this burner, again, are driven by the board, which gets a signal from the flow rater. That's the simple flow of things. As soon as the flow rater gets a signal, sends that signal to the board sends a signal to the gas valve. There are 300 burners in here.
Wow.
What happens is this gas valve will modulate up and down to give us the output temperature coming out here, coming out this pipe right here, the output temperature that we want within 2 degrees.
In order to maintain that temperature?
To maintain that temperature. We will always get an output temperature that's within 2 degrees, which is being measured by thermistors. This is a thermistor right here. Basically what that's doing is measuring the output temperature. Again, sending a signal back to the board. The board's saying, is our output temperature correct? And it's going to modulate these burners based upon what that output temperature is. So it's a very sophisticated appliance. And what's happening is these burners will modulate in 1 BTU increments from 15,000 to, in this case, 180,000 BTUs, always giving us the correct water temperature. So the scenario is when somebody comes in and turns on the hand sink in the kitchen, they're going to wash some dishes, then the flow rater detects that we may only have, 1.5 gallons a minute of flow. A gallon and a half a minute of flow is probably only requires 40,000 BTUs of burner to heat that water up fast enough to give us that output set point temperature of 120 degrees or whatever it is.
With a system this complicated, this sophisticated, how long would you expect it to last without needing some kind of service?
Well, a year.
Yeah. Do they need yearly
do.
maintenance?
They do. That wasn't a trick question, was it?
No, it wasn't.
Okay.
I'm just wondering if an inspector walks into a home and sees a Renai or something similar, and it's 3 years old, and there's no indication that it's ever been serviced, then he should probably be recommending service.
Should be suggesting service, because one of the things that happens with hot water, what happens is you do have some precipitation of calcium. So if you have a high calcium content in the water, we will have some precipitation of calcium onto the copper. That does not happen with cold water. So you don't have sediment issues with a typical with a tankless water heater. But what you do have is scaling, okay? Just like your coffee pot. And what you need to do is clean that scaling out of the system, and you need to do it about once a year or more often in the case of high calcium carbonate content water.
Can those scales break loose and clog orifices in there somewhere?
Not orifices, but what can happen is there's a little screen, and this is open, but right there, there's typically a screen in there that you can see the screw on it, so you can just pull the screen out, and that screen, it's a micro screen. It does protect the system from getting any small pieces of dirt going through. Because if you get any dirt going through this flow rater, it could clog the wheel and stop the computer from reading a proper, giving a proper reading to the burner.
And then it would shut itself down then, I guess.
Usually, typically what we see is not shutting it down so much as giving us an improper reading. So it might think that you have 3 gallons a minute of flow going through it when you only have a gallon and a half. And so maybe you can't take 2 showers at the same time, which typically you should be able to do with one of these units. So flow drops is what happens.
So in making a recommendation for service, should an inspector recommend a plumber?
No, not necessarily. Plumbers are good at drains and installing toilets and sinks and things like that. Generally speaking, plumbers are not the people to be talking to about this. It's a little like talking to your family doctor about open heart surgery. Not recommended. These are a computerized unit. They require some pretty extensive training and knowledge of the internal workings of the unit to really be able to understand how they work, maintain them, replace any parts if they go bad. The beauty of most of the good tankless water heaters that are on the market is, if you notice, there's a lot of these little things, Phillips head screws. That's pretty much all it takes to work on this unit is a Phillips head screwdriver. In fact, during the training course, that's what they do. Is they set the unit in front of us, set a Phillips head screwdriver beside it, and say, take it apart. But it's always a matter of knowing which screws to take out.
A Phillips head screwdriver and a head full of knowledge.
That's right. It's not just the Phillips head that you need.
So in addition to being an HVAC specialist, an inspector should be recommending a qualified HVAC specialist.
Somebody who's certified by that company to work on this product. Just like we're into specialization with cars. A lot of automobile manufacturers are recommending a person who is specialized with that particular brand of automobile, because all the computers are different. Everything's different in the new automobiles because they're all very sophisticated.
Right.
Yeah.
Do they vary a lot from brand to brand as far as who's qualified to work on them? Well, I guess you just answered that question.
Yeah, and it's going to be a lot more so. We're going to have more people specializing in different brands because of their allegiance to that brand. I mean, that's the thing that we're seeing is people are getting one brand, spending less money on one brand than another, so they're getting that, sticking with that brand, and they are all basically the same concept, but the workings and the parts are all proprietary in every single tankless water heater. There is not one part in this unit, and it's the same of any tankless water heater, that is not manufactured by this manufacturer.
Yeah.
Why is that different? If you look at a furnace, it's the opposite. In a typical gas forced air furnace, there's only one part to that furnace that's manufactured by that manufacturer, and that's the heat exchanger.
Oh.
Everything else is Fasco, General Electric, Honeywell, Robert Shaw, White Rogers. They're all parts that are bought from other manufacturers. That's not the case with tankless water heater. Everything inside of this unit is proprietary and has to be replaced with the same part. They don't interchange, unfortunately.
Right. So are we finished with this? Let's see. We've got the 300 burners in the burn chamber. Did we cover this?
This is the heat exchanger. This is the heart of the unit. And what happens is, again, as the water flow comes in and passes up into the heat exchanger, that's where, because of the flow rater, that's how we're getting the flow to, or the signal to the board to the gas valve and to the burners. What's happening is there's a series of coils inside here, and you can see them on this side, through which the water is flowing, and underneath we have the burners. The heat exchanger is the part of the system that is most likely to need replacement. To get back to your earlier question, what are the maintenance issues? What you're going to see if the unit was not properly installed, or it has not properly been maintained, because the heat exchanger is what gets scaled. So the heat exchanger is what where that scale needs to be removed by the process of white vinegar pump. We actually pump white vinegar through the system. We actually have kits that we manufacture that homeowners can get that'll help people to be able to do that easily. What happens, though, is this heat exchanger, if it gets overheated too many times because it hasn't been cleaned properly, will develop a leak. One of these seams or one of these pipes will split or will crack. Or if this unit is outside and is not freeze protected properly, or we have an outdoor unit that's not rated for this freeze protection zone.
Mm-hmm.
So, for example, Noritz, great unit, but they're only rated to 5 above 0 in freeze protection. This unit is rated to 40 below. This system right here, this is basically a heater. And what that heater does is it keeps the unit from freezing. It protects the unit from freezing.
So there's no extra insulation that goes on this housing. That's it for keeping the heat exchanger.
Basically, just keeps the heat exchanger warm. And what happens, though, is it is predicated on having electricity.
Right.
That's the problem, is this unit will freeze protect itself to 40 below 0. But the catch is you got to have electricity to it. It doesn't draw a lot of power, but you have to have that power to the unit. Because what will happen is if it continues to drop in temperature, the computer, which again is the brain of the unit, says, uh-oh, we got a problem. This thing's dropping in temperature, and the heater's not taking care of the problem. So what we need to do is we need to fire the burners. And what it'll do is stage fire the burners, just 1 or 2 burners here and there to keep this heat exchanger warm. Mm-hmm. It's pretty ingenious how it works.
So the problem with the heat exchanger with failure is not so much thermal cycling like it is with maybe furnaces. It's more buildup of scaling.
Yeah, buildup of scaling. Mm-hmm. And heat exchangers, I mean, there's a 10-year warranty on most of the heat exchangers, these 10 or 12. Typically, a heat exchanger under standard load conditions, which is domestic hot water, typical usage, should last 25 to 30 years. But again, the beauty of these is it's a component system. Anything that goes wrong inside here can be replaced with a Phillips head screwdriver, and that's the beauty of it. If something goes out, the heat exchanger starts to develop a leak. In about 25 minutes, a good technician can have this heat exchanger out of here.
Wow.
And have a new one in,
Mm-hmm.
pop it in. So makes it easy.
So this is the exhaust fan.
That's a combustion fan. That's correct. And on an indoor unit, typically you're going to see a black boot right here, and that boot is connected to the combustion intake, which is this part right here that we saw. Mm-hmm. And then the exhaust, of course, it's pushing the exhaust out the inside pipe. On an outdoor unit, of course, we don't have to have all that because all we've got is the one slit.
Right.
It is the intake and exhaust.
Are there any standard venting dimensions, like distance from a window, that an inspector can be aware of when looking at an outside unit?
Yes. And the word to the wise there is an inspector should have the book for the unit. Because, again, every unit is different. Mm-hmm. And every tankless water heater manufacturer sets its own standards for vent clearances to different things.
Typically, we don't have the manual, so we just have to give it our best shot. So, you know, if we have a manual handy, it's good to look at. But if you just had to stand back and look, are there any dimensions that are common to all these things? All tankless water heaters, like distance from a window, distance above the ground, anything like that?
Typically, 12 inches above the ground is what you're looking for the vent. If it's an outdoor unit, you really generally don't have that issue because the unit's going to be at least, this is 24 inches high plus the pipe cover on the bottom, so it's usually typically 30 inches above the ground where our vent is.
About this high? You'd see it mounted about this high in the house?
Well, plus the pipe cover box that's underneath it. So it's usually about 30 inches off the ground, so it's not a problem. But where we've got to come out through a rim joist, we run into situations where a rim joist is not 12 inches off the ground, and you see the vent pipe coming out. We know it's too low. You can just look at it and tell. If it's less than 12 inches above the ground, snow's going to cover that thing up. And when it does, it's going to cause problems for the venting. Typically, a Rinnai, for example, is 1 foot from an opening door or window or any kind of intake. Power intake, it's 4 feet. It can't be right directly below a deck. You can't be right next to a door. There are some typical things that you can look for, clearances. Figure on a foot, though, at least, for just about every unit for the vent clearance to an opening into the house.
From grade?
No, to an opening into the house. Yeah, like a window or door or anything like that. Figure at least a foot. The other thing to look for, the other red flag for an inspector, there are a few of them, condensing units, air conditioning condensing units. We typically don't want to see exhaust gas blowing right on a condensing unit. Why? Because it's pulling, somebody could be taking a shower, it could be pulling that exhaust gas in over the condensing coils. Exhaust gas has sulfur dioxide, carbon monoxide, and water vapor. Those are the 3 basic elements of exhaust gas. Well, what happens when you put sulfur dioxide and water together? You get sulfuric acid. Okay, so you don't want that running across an air conditioning coil. You want it typically at least 6 feet away from a gas meter, because this is a power intake. You don't want to be pulling raw gas into this unit. Not a pretty sight. You typically want to be not directly below an electric panel and have some distance away, if you can, off to the side of an electric panel. So these are some of the...
For the same reasons, because of corrosive gases.
Exactly. You don't want that going up into the breakers.
Well, is there anything, let's see, the controls here we'd see inside. We wouldn't see those outside.
Correct, yep. And the control is a digital control, and it does have a program button whereby we can find out a lot of things about the unit. If it has ever shut off on any code, again, what the computer does is it regulates the system. If, for example, someone were to shut the gas off to this unit, a code 12 would flash here. The homeowner would come down and see it's flashing a 12 and call, hopefully, the technician who put it in and say, it's flashing a code 12. Well, that means that it doesn't have gas. Some reason someone has shut it off. Or if the vent is blocked, it could be a code 10 or a code 12. Actually, some of the codes overlap. But by pushing the program button, we can find out what the codes are. We also... With this unit, we can find out what the flow through the unit is at any given time by pushing a series of buttons on that controller. Now, everyone's going to be different, so there's no sense in really showing you this particular unit, but there's a lot that you can find out from that controller other than just the output set point temperature.
At least we know that it's possible to get information from the display window.
Tremendous amount of information from that, which comes straight off the computer.
Do inspectors need to worry about insects?
Yes. Yes.
Yeah.
That's a typical problem. We don't find it on outdoor units. I know that sounds strange, but we really don't find problems with insects on outdoor units.
Because they run enough to blast any insects out of there?
Well, I just think that insects stay away from them because of this little slit, and it's like a metal vent. With this vent, because it's pulling in through a plastic, and this is cool to the touch, insects might be walking around on this thing. They're not going to walk around on this because it's hot.
Yeah.
Especially when the unit's, well, only when the unit's running, but it is hot. This is where the heat is. We see these typically pull in miller moths, bees. I mean, I've seen situations where we had pretty much every species of bee inside of that combustion fan, because that's what it'll do, is it'll suck it right into the combustion fan. And that combustion fan will start to be noisy. So if an inspector sees one of these that's noisy, almost always what the problem is. There are insects lodged in that combustion fan, and it's getting it out of balance.
So I suppose the same thing could happen with seed pods from
Oh, sure.
from surrounding trees, that sort of thing. Any
And
kind of restriction.
Any kind of restriction. Cottonwood,
Mm-hmm.
you know, that can, if it's sucking way too much. I mean, generally speaking, it will suck it into the burner system, and the burner system will burn anything that comes in there. If it's small enough a particle. If it's not, if it's like a bee or an ant or something like that, it's going to get lodged in here. It's not going to make it to the burners.
And then it'll start making a rattling sound or something like
Yeah,
that?
well, it's going to whine.
Uh-huh.
It's going to make a whining sound.
Uh-huh. Dave, can you talk a little bit about the differences between a conventional water heater and a tankless water heater?
Sure. A tank-type water heater has some amount of storage, 40, 50, 60, up to 100 gallons of storage. And what's happening with a tank-type water heater is that water's being heated all the time, 24/7, which is why people are going to tankless water heaters, because of the energy savings, primarily the space savings, the lack of maintenance, the lack of having to schlep a water heater up out of the basement every 5 or 6 years, lack of sedimentation that we talked about, and primarily the lack of running out of hot water, which is what you see typically with a tank-type water heater. With a tankless water heater, it's impossible to run out of hot water. It's impossible to ever be in a situation where you're not getting hot water out of the system if it's working properly. But what we do have is a certain amount of hot water that's available per minute, or flow that's available from a tankless water heater.
Mm-hmm.
And let's face it, you have a burner system that can only heat the water so fast.
Right.
So a typical home, what a home inspector needs to look for to size, to make sure that the tankless water heater is sized properly, is how many fixtures are in the house, and what is the maximum flow that that household could be using at any given moment. And what we typically like to do is match that flow up to that demand if we can. You can't always do that, and sometimes buyers need to understand that they may not be able to turn everything in that house on and get flow out of all those fixtures.
So can an inspector test that by turning on a representative number of fixtures, hot water fixtures at one time, and timing how long it takes to run out of hot water?
Absolutely. And what's going to happen with most tankless water heaters is that when that flow rate, that maximum flow rate that's available because of the size of unit we have is exceeded, the flow will drop in all of those fixtures. So for example, we have 2 showers going, which typically is the maximum flow available from a tankless water heater here in Colorado at the altitude where we are, as well as the cold incoming water temperature that we have. Here in Colorado, our water is coming in at 40 degrees in the wintertime and 50 degrees in the summer. So that's another thing that an inspector can measure. What is our incoming water temperature? If he wants to, it's real simple to get, a laser thermometer.
Yeah.
I mean, it's something I'm sure that they carry with them. Or, they
should.
should. Measure the incoming water temperature. Typically, we want to see in Colorado an 80-degree rise. There are other parts of the country where you don't size for an 80-degree rise. Southern Florida, for example, the water's coming in at 75 degrees. If the water's coming in at 75 degrees, to get it to 120 is only a 40-degree rise or 45-degree rise.
Dave, what does an inspector need to know in order to determine whether or not the tankless water heater is sized correctly for the home?
Well, typically, we do have some flow rates that oftentimes are posted on the side of the unit. Again, if we don't have a manual, we can look at the flow rates for the particular unit that's there and take a look at the how many fixtures there are in the house and how each one would affect the flow coming from this unit. So for example, the typical hand sink is 1.2 to 1.6 gallons per minute of flow. The typical shower is 1.8 to 2.2 gallons per minute of flow. And what we're talking about here is flow from 40-degree incoming water to 120-degree. That's what we need to look at for colder climates. For warmer climates, it's different. Mm-hmm. But you just look at what temperature the incoming water is. Typically, a dishwasher is 0.9 to 1.1 gallons per minute. Where we run into issues are bathtubs, jacuzzi tubs, and old-style washing machines. because all of these things do dump a tremendous amount of water at once. If you've ever watched a jacuzzi tub with a Roman faucet on it, there's 6 to 7 gallons per minute of water that thing's dumping. That's way more than any one tankless water heater, can handle before that flow is dropped. So, you know, typically if an inspector goes into a home that has a jacuzzi tub and there's only one unit, and he measures the flow at that jacuzzi tub at 6 or 7 gallons a minute, which he can do with a stopwatch and a bucket, very simple, gallons per minute, then he needs to know that this unit is not going to be able to handle that plus anything else in the house without a reduction in flow.
Right.
And again, it's about education. It's about the person who's buying that house understanding what it is they're getting and that they're going to have to adjust their lifestyle to a tankless water heater.
And when you say reduction in flow, that actually means reduction in flow, not that the water will get cooler like it does with a conventional water heater.
That's correct. When a conventional water heater runs out of hot water, it's done, and until it comes back, it's cold water. It's no longer hot water. Tankless water heater, the more modern, the newer units, what will happen is that flow will drop, yes. On the older units, if they're running into some of the older Aquastars, some of the older Palomas, some of the older Takagis, the thing that they're going to see is that they don't adjust the flow. There's no capacity of the unit to actually adjust the flow of water through. That's what this flow rater does. It actually adjusts the flow of water so it comes out slower to keep that same output temperatures that you have set on the controller. The older units are much less sophisticated than that. They don't have a computer. They have no way to do that. So they're going to drop the temperature and people are going to get cold showers out of the old units. Yep.
Dave, are inspectors likely to see electric tankless water heaters? And what about point-of-use water heaters?
There are electric tankless water heaters manufactured. The problem that we see with them is that they require a tremendous amount of electricity. Obviously, if anyone's ever cooked on a gas stove versus an electric stove, the difference in time that it takes to heat water on a gas stove is considerably less, isn't it? So typically heating water with gas instantaneously like this, a continuous flow, takes a lot less energy to do. So what we see with electric tankless water heaters is they could consume up to 140 amps of power at 220 volts, and most homes don't have that capability. So we don't really see a lot of them out there, no. And as far as point-of-use units, the only point-of-use units that are available in the United States are electric units. So we're kind of back to that same problem. What we really see for point-of-use are very low flow, ones that can make a cup of tea, for example. You got 120 degree or 130 degree water coming out, but it's a tiny amount of 120 degree water.
So you might usually see those in a kitchen, just serving the kitchen sink and maybe the dishwasher.
Exactly. I mean, you go to Europe and Asia and places across the puddle, and you do see gas point-of-use water heaters, but they are illegal here. There's no way to put them in.
What about the cost advantages in installing a tankless water heater?
Well, a tank-type water heater, of course, is considerably less than a tankless water heater. But one of the things that has come to the forefront recently is the new NACA standard. The National Appliance Energy Conservation Act has mandated for tank-type water heaters a new standard, and that actually has thinned the walls of the heat transfer tube and at the same time the jacket of the new tank water heaters. So when you go out to buy a new tank water heater today, the typical life expectancy is 3 to 5 years of a new tank-type water heater. And that's by government mandate.
And that's just because of thermal cycling, heating and cooling, and stressing the metal over time?
Well, as we know, with a tank-type water heater, it's usually a glass-lined, rolled steel tank. And what happens over time, yes, is that through contraction and expansion, that glass eventually cracks. Well, now we're relying on that metal to keep that water in. Now, if the metal is 1/3 the thickness that it used to be, it's going to take a lot less time for that tank-type water heater to explode and go all over the place.
So why did they do that?
The government issued a mandate. As I said, the NACA standard was brought about by Reagan in 1978. If you see the yellow guides, like this, energy guide, you see that on every appliance. That's NACA, National Appliance Energy Conservation Act. And that was started back in '78 and applied to furnaces and air conditioners, refrigerators. Every home appliance has that yellow energy guide on it. Well, in 2004, they realized that they needed to do something with water tanks because they are the most inefficient appliance in any home, bar none. Less efficient than even an old furnace.
So they reduced the lifespan?
So they reduced the lifespan because their thinking was, if we can thin the wall of the heat transfer tube that goes all the way up through the middle of the tank, we're going to get more heat into that water quicker, aren't we? So that is correct. But what did they increase the efficiency by? Any guesses? 1.5%.
Wow.
1.5%. So the new water tanks save all of $10 a year over the old water tanks. They're $100 more, and they're going out every 3 to 5 years. What we've seen is tank-type water heaters that are less than 4 years old, where the sides split out of them. They don't leak anymore. The bottoms don't drip, drip, drip. They explode.
You mean the tanks will rupture before they discharge at the pressure relief valve?
Mm-hmm. Yeah, and not because they're overpressuring the relief valve, because the seams can't handle it anymore.
Wow. I'm surprised they're not changing the pressure relief valves to
They can't. You've
accommodate
got 80
that.
pounds of pressure coming into most houses. You can't.
So how serious are these explosions? I mean, are they
I've
just
seen
little
basements
splits?
that are totally flooded as a result.
So the force of the explosion itself is not what causes the damage. It's
It's
a
just
small
the fact that there's
explosion.
50 gallons of water coming out all
Yeah.
at once with 80 pounds of pressure behind it, and there's
Yeah.
no drain made that's going to handle that volume of water all at once. The old water tanks, I mean, we typically saw them drip, drip, and people would call and say a pressure relief valve is dripping or there's a drip underneath it, which means there's a breach somewhere. But it's, the old tanks had such thick walls that they could handle it for a while. The new tanks cannot.
So inspectors seeing water heaters manufactured after what date should be watching?
2004.
2004.
The new NACA standard came in 2004. So we're seeing tanks that are at the end of their useful lifespan that were bought in 2004. All the time. Every day. It's crazy.
And so there's no visual evidence of impending rupture of the tank. It's just
That's the problem, is they don't warn you. And so these tank manufacturers, of course, are loving it because they're selling consumers tanks every 4 to 5 years. The good news is it makes a tankless water heater an even better investment because, and I'm not trying to sell tankless water heaters here, even though I do.
Well, that's good information to know
Yeah,
about,
absolutely.
especially about conventional water
I mean,
heaters.
what people are looking at in order to justify the additional cost of a tankless water heater is what would I spend otherwise? If I went out today to one of the local hardware stores and bought myself a new water tank and had a plumber come put it in, what am I talking about? Well, typically you're talking about $800 to $1,000. Pretty much what you're looking at. Typically for a tankless water heater, $2,500 to $3,500.
But then you're looking at the tankless water heater from the standpoint of life cycle analysis. So you're looking at it you're looking at the cost over maybe 25 years, and comparing the cost of conventional water heaters that way, rather than the cost of the construction, the time of construction, or a one-time cost.
Right. Well, the beauty of it is, Kenton, that you're not looking at it over 25 years. You're looking at it over 5 years. That's the beauty of it. I mean, the reason I say that is a tank-type water heater now has a longevity of about 5 years.
Oh, I just meant that you'd be looking at the lifespan of a tankless, which might be 25 years, and compared to the one-time, the single cost of a conventional water heater, which you'd have to replace every 3 to 5 years, somewhere around in there.
Yes.
If it was manufactured after 2004.
Yeah. So you would buy, if that's correct, which we think it is, we're seeing it already, you'd buy 5 water tanks over the lifespan of this unit. 5 water tanks at $1,000 each. It's $5,000 versus $3,000, and then that doesn't even take into account the energy savings, which are real, anywhere from 30 to 70%, depending on the number of people in the house. Now, this is where it gets a little interesting. The truth is, the less people there are in the house, the better the energy savings from a tankless water heater.
How is that?
A tank-type water heater is only efficient when there are people using the water. A tank-type water heater is 0% efficient when there's no one there to use the water.
You're paying to keep it heated constantly.
Exactly. There is no useful heat from that tank water heater unless somebody's there to use it. Tankless water heater is only using energy when someone is there using it, right? Opening a tap. All right? So, a tank-type water heater, if there's only 1 or 2 people in the house, gets a whole lot less use. If there's 10 people and living in that house and they're taking showers all day long, it's more like a tankless water heater then, right? Because you're continuing to heat the water, but you're doing it. You have a purpose now.
Yeah, hot water's
You're actually heating it for someone.
Yeah.
Wow, what a concept. With this, it's only heating water when you need it. So we see, I mean, we've had several situations where we go in and the homeowner, there's 2 people living in the home, and they drop from they drop to the minimum therms, less than 1 therm. You know, from say 15 or 12 to 15 therms with a tank water heater in that house to less than 1 therm because there's only 1 person in the house. And he's not using hot water.
Right.
So with a larger family, we still do see savings. But if there's any rule of thumb, any time you have more than 4 people in the house, you're probably only talking about a 40 to 50% savings. If you've got less than 4 people in the house, it's probably going to be over 50%, possibly as much as 70% savings.
Are there any incentives? State, federal?
There's a federal tax credit that's available. It was available last year, $300, and I believe that is available again this year. And that's for any tankless water heater.
And it probably varies from state to state also.
No, that's federal.
Okay.
It's a federal tax credit, and you get that on your taxes. So one of the typical problems wanted to just mention about tankless water heaters is the lag time. The biggest drawback to a tankless water heater, other than of course that you only have so much flow available, as we already talked about, is that you are going to wait longer for hot water with the tankless water heater, any tankless water heater, than you are with a tank. That's probably the one benefit of a tank-type water heater, is because it's heating water all the time, it's thermally siphoning hot water up into the pipes, isn't it? Number one. And number two, you don't have to wait for the thing to fire up when you turn on a tap. It's already done. The hot water's already there. So what we see with a tankless water heater is anywhere from 15 to 20 seconds of additional lag time if the tankless water heater is installed in the same place as the original location of the tank-type water heater.
So how do we get around that?
We do that using this. This is the Metlin demand system. A Metlin demand system, there are other demand systems available. Basically what this is a recirculation device. And it is a radio-controlled recirculation device. There is a small button that looks just like a doorbell or a garage door opener. And this is the receiver, and the receiver is hooked into this pump. This pump is installed generally under the farthest fixture away from the tank or tankless water heater. You can use it with a tank too. But it's much more important to do it with a tankless water heater because what's happening is it's taking longer for the water to get there. And the consumer's saving energy, but they're wasting water. So this is how we overcome that problem. By installing this under the sink, the farthest fixture away, and it hooks up to existing plumbing. See, it'll hook straight up to existing sink plumbing, plugs in. Usually we put an outlet under the sink to plug it into, run this and hang this on the wall, and then they can carry this around with them. This is radio controlled. This button can be in their pocket, velcroed to a wall, in a sink drawer. They can carry it around. Anywhere they are in the house, they push that button, and as soon as they push that button, this pump's going to come on, circulate the hot water, the water through the tankless water heater, circulate it out to that farthest fixture, passing by every fixture on the way. Because if it's the farthest fixture away, every other fixture in the house is in between the water heater and this pump. So no matter where they are in the house, they push that button, and they've got reduced wait time for hot water, and they're not watching water go down the drain while they wait. That's the important part.
You make up by lag time. You make up for lag time by pushing the button, having it circulate within the pipes instead of running water out, wasting water.
Exactly. This is a water-saving device. It's not an energy-saving device. This is an energy-saving device. But the misconception these days is that this will save water. It will not save water unless you can put one of these at every fixture.
Yeah.
And at $3,000, that's going to be just a tad pricey, and I don't think guys are going to run into that. So this solves that problem.
And this is pretty easy to retrofit, it looks like.
Oh, yeah. I mean, we sell them all the time to plumbers. Even plumbers can put these in. Oh, did I say that out loud?
So do people install these in conventional systems?
Yes, we see these all the time with water tanks, because you get into a house that's 3,000, 5,000 square feet, and the farthest sink away could still be waiting a long time for hot water. So we see these typically in bigger homes. There are many different sizes. This one's an S50, which is made for under 50 feet of run with a tank-type water heater. One of the things that guys are going to run into is these installed with tankless water heaters, and they don't work because they're not big enough. It takes a bigger pump to overcome the head pressure that's being created inside here. Look at the pipes that are going through here. You've got a lot of water moving in different directions, which creates pressure. Mm-hmm. And FYI, that's how this thing works. This is basically a pressure cooker is what it is. How can I get 3.5 or 4 gallons a minute out of something this small with just a burner system and a heat exchanger? Well, we do it with pressure. So you have to have a recirculation system that's going to be able to overcome the pressure that's built up inside of this unit.
Because the pipes are limited to 3/8 or ½ inch? Or
5/8 or ½ inch. Yeah. Actually 5/8 or ½ inch. And there's a lot of piping going through here and a lot of different elbows, things like that. So you're creating static head pressure inside of the unit.
Each elbow, each turn of loop would be a restriction, which would
cause additional pressure. But that's what you're trying to do.
Yeah.
You're trying to make pressure inside of this unit so that you can get the water heated up faster, because pressure creates heat.
Dave, is an inspector likely to see water leaking from this?
It's pretty unlikely. Usually, if there is a water leak, it's going to be from the valving underneath, not from the inside. If there is a leak on the inside, it's generally going to be the heat exchanger, which means there's a problem with the heat exchanger and probably needs to be replaced.
And it would be coming out the bottom anyway, probably.
It'd be dripping out the bottom. And when we have seen leaks, it's dripping through one of the holes in the bottom of some sort, and it's usually coming from the top of the heat exchanger, one of these pipes, or one of these connections. But we don't see it very often. We really don't, especially on the newer units. Some of the older ones, I mean, they're eventually going to leak after 25 or 30 years, and that's what's going to happen, is the heat exchanger is going to spring a leak.
Do inspectors need to be looking for a pressure relief valve?
Pressure relief valve, according to the new International Plumbing Code, is not required on a non-tank type vessel or a non-storage vessel, and this is a non-storage vessel. However, the manufacturers have not caught up with the ANSI standard and the new International Plumbing Code, and so they're all still listing on the side of the appliance that a pressure relief valve, a qualifying pressure relief valve has to be installed. And this is all from the old plumbing codes, and they just haven't taken it off, and the inspectors always defer to whatever's on the side of the unit. Right. So the answer is no, it's not necessary, because you're never going to build any pressure with this, are you? There's no storage. The only time that there's any fire is when the unit's being used, so there's never going to be any pressure built up. However, since it's still on the side of the unit, yes, you have to have one.
So you actually have to have one because it's written there. So inspectors should call it out as a defect if they don't see one.
As non-compliance with code.
As long as they see it written on the side of the
yeah, exactly. It's not going to hurt the unit,
right,
but an inspector will look for that.
For liability reasons, if you see something written as required in the label, typically you're required to.
And as much for warranty reasons as anything, because if it says it on the side of the unit, then the manufacturer typically requires that to comply with the warranty.
Dave, is there anything else an inspector should be looking for when he's looking at the exterior of a tankless water heater?
Proper valving is probably one of the most important things. What we need to do is make sure that there is a service manifold at the bottom of the unit, which would allow us to shut the inlet and the outlet ports to the tankless water heater so that the water could be drained out of it, and also so that the flushing could be done, the periodic flushing that we talked about. And particularly with an outdoor unit, we want to have that valving on there so that they can drain the water out before they leave on vacation in the middle of the winter, so that there's no freeze-up problems on in the unit.
So a service manifold being 2 shut-off valves?
And 2 drains. spigots that can actually be hooked up to a hose to drain the unit, and also to introduce the white vinegar flush that needs to be done every year.
So an inspector should look for a couple of ball valves and a couple of drains.
Of boiler drains, right.
This has been good, Dave. Should we go over to a home and look at an installed system?
Sounds great, Kenton. That'd
Great.
be awesome.
Dave, this looks really complicated. There's a lot of pipes through here. Is this as complicated as it looks?
Not really. It's actually a fairly simple system in a lot of ways.
Simple? Maybe you could expound on that.
Just from the standpoint that really we have three separate systems going on here. We have our heating, we have domestic hot water, and we have solar. So we really only have three systems, and all of them should be integrated together to work together to do the functions that they need to do.
Well, that makes sense. And are they?
No, they're not.
They're not?
They're not. No. And this is a problem that a lot of solar systems, people who install solar systems encounter, is how to integrate everything so that we're getting the most use out of the sun or out of whatever alternate source of energy we're using. And in this case, it's not being done optimally. It's being done, and it's certainly going to help the bottom line or the energy usage of this home, but it's not done as well as it could have been, I don't think.
So we've got a great big hot water tank here. Looks like 300 gallons or something like that.
Yes.
And this is not supplying pre-warming water for these two water heating appliances?
No. This is only preheating the water for this appliance right here. And this appliance, interesting, what we were talking about earlier was tankless water heaters, wasn't it?
Mm-hmm.
Does that look like a tankless water heater to you, Kenton?
No, it doesn't.
No, it's not.
Well, maybe you can explain what some of this piping does and how these are integrated.
Okay, yeah, let's simplify things. What we have right here is this line coming in is the main cold water line. The best way to simplify this in what's called a home run system like this is there are three different colors being used. There is blue, there is red, and there is orange. Blue is cold, red is hot, orange is heating. So
Hydronic heating.
Hydronic heating. Oh, one more, excuse me, yellow. What would yellow be?
Gas.
That's right. So there really are four colors: blue, red, orange, and yellow. All of these pipes over here that you see on this wall are heating. So we'll talk about that in a moment.
Actually, we have copper also.
Another color. My favorite, actually, the most expensive color. All right, so what's coming in, the first place that this water line goes is it branches off to this system right here. The system right here is what's known as a home run system. It's basically a manifold. As you can see, there are blue pipes here and there are red pipes here. What's happening is the blue pipes are coming in, they're returning back from the appliance, or they're taking cold water to the appliances, each one of the outlets, the sinks, bathtubs, all of that.
So this is domestic hot water.
This is both cold and hot that are coming in. There's hot and there's cold. The cold is the blue one. In this case, they use the orange, so it's the only place where the color scheme doesn't match.
So the way that inspectors can tell that this is hot water for the plumbing fixtures is that it doesn't have zone valves.
Correct.
Okay.
It's basically cold water coming in, hot water going out. So that's basically our domestic hot water system. So what's happening is we're feeding the cold water here, which is being branched out through the manifold to all the different places in the house that require cold water, which is every fixture. And then hot water is also coming in and branching out to all the hot water supplies. Okay? Where the hot water is coming from for the manifold is this pipe right here. Well, that pipe is coming off of this tank, isn't it? But there's also a split here. Now this split is what's called a mixing valve. And the reason the mixing valve is here is because, and this is something that inspectors need to look for. One of the things that happens with mixing valves is they typically will get gummed up. They should really be exercised about, and I don't mean like bad spirits in the house. I mean, these need to be moved back and forth so they don't get stuck.
So an inspector should recommend that be done once in a while.
Yeah, because what happens is these will get stuck and you can't move them and you can't change the temperature.
Is that with an annual service, or is that something a homeowner can do?
Homeowner can do it.
Yeah.
And they should do it. They should just make themselves a note to do it. And it's a good thing for an inspector to recommend.
How often would a homeowner do it?
Once a year. Okay. Once a year is good enough. The problem is they do get some calcium in them, and of course that gums them up and they don't move as well.
So there should be a mixing valve seen wherever a supply splits like that?
No, not necessarily. The only time a mixing valve is really necessary is when we have the potential of supplying water that is over 140 degrees in temperature. 140 degrees is the plumbing code's maximum for safe water temperatures. So if we're supplying a potential of more than 140 degrees of water temperature, we definitely want to have a mixing valve. Well, the question is, how is it that we're possibly supplying it more than 140?
Mm-hmm.
Well, the solar tank is going to be, if the sun's shining and those panels are doing their job, you could have up to 200 degree water coming into this unit. So if that water's coming out and going through the tank and coming out of the tank, then we want to have a mixing valve so that we're not introducing more than 140 degree water into the manifold and into the rest of the house.
So supply for this electric water heater is this pipe here, which goes over and comes out of the top of that big tank.
Right, which is the good part of this idea. We're actually supplying solar hot water to the house. The problem I see with this system is that we're supplying it via an electric water tank. And that's the problem we talked about before with water tanks, is we're heating water 24/7, aren't we?
Yeah. Well, I was thinking that maybe since there was hot water coming out of the storage tank, that the hot water heater, the electric hot water heater, might not run very often. Can you explain why that wouldn't be true?
Well, you know, if people didn't want to take a hot shower in the morning, that would be true. But the problem is that all night long while people are asleep, in order for people to be able to take a hot shower in the morning, this thing's heating water, isn't it?
All night long.
All night long. And while people are on vacation or whatever, or while they're at work, unless they turn this switch off, that thing's heating water. Now, what happens when we turn this switch off? It turns off the element inside of this tank, doesn't it?
Mm-hmm.
Okay, so what's the temperature of the water in this tank?
Well, it would be whatever temperature was last came out of that tank.
Mm-mm.
Or
Temperature of the water in this tank would be whatever the temperature of this room or below, whatever water goes to.
Oh, after it sat for a while?
After it's sat for a while, which is generally about 60 degrees. If you're in a 70-degree ambient temperature,
mm-hmm.
the water temperature inside of an insulated tank will generally be 10 to 12 degrees below the ambient temperature. If it's 70 in this room, the water in this tank is 58 degrees. Now, I don't know about you, but I sure wouldn't want to take a 58-degree shower. So we got 50 gallons of 58-degree water sitting here unless we turn this on. Well, if we turn this on, we got to heat that water all the time. This is not an instantaneous water heater. This is not an on-demand water heater. This is not a tankless water heater, is it?
No.
Okay, so that's the problem I have with this system. Otherwise, it's a great system, but why would one spend $20,000 on a solar system that's basically only replenishing this tank once that 50 gallons is gone? Which means that we really have to have at least 4 people taking showers back to back before this tank is going to be replenished, and the solar is going to be introducing hot water into this tank, don't we?
That's right. The first one won't empty the tank. The second shower won't empty the tank.
By about the 3rd or 4th shower, if they're reasonable showers, this tank's depleted, and now, great, now we're using solar.
Although it doesn't, you don't have to deplete it completely before water will flow into the tank.
Absolutely. I mean, the solar is replenishing this tank, which helps the energy usage. But the only time it helps the energy usage is when water's being used. So why would you not put a tankless in here? Because the only time a tankless water heater is using energy is when water's being used, right? Well, that's the whole idea behind a tankless. Mm-hmm. That's why it would have been a much better solution for this particular situation.
So there's 2 systems, the domestic hot water system and the solar thermal system, which heats water from panels which are up on the roof and which we won't go into too much detail over right now. The third system is this. What do we have here?
This is the hydronic heating system, or the boiler system. This is one of the new wall-hung boilers, which some people will call a tankless boiler. And the amount of water being stored inside of this system is pretty small compared with the older boiler systems. And we were talking earlier about modulation. This is a modulating boiler. But we were talking about all the 300 burners inside of the tankless water heater. This basically has one what's called an in-shot burner, which is inside of the chamber where the water is. The modulation on this is a 5,000 BTU increment.
Now, if an inspector walks in here and he doesn't know a lot about these systems, this doesn't look that much different from the tankless water heater we just looked at. How do you tell the difference?
Well, first of all, if it's a boiler, it's going to be capable of much higher water temperatures, as we talked about. This unit will put out 180 to 200 degree water temperatures, whereas a tankless water heater won't do that.
So you're looking for a data plate to tell the difference? Or are there components on here you can look at which will...
I hate to say it, but you almost have to know that that's what it is. Yeah, almost have to know that it's a boiler because of everything's getting smaller these days. And if you don't know what it is, you're probably not going to be able to tell without... I mean, the data plate probably won't have the temperature differentials on it. It'll just have the BTU ratings.
Mm-hmm. Well, I guess the concerns are still the same. You still want to make sure that it's vented correctly and that there aren't any problems with the supply or leaks.
Correct.
So basically we're looking for the same types of defects on the tankless boiler, walking boiler, that we are on a tankless water heater.
Yep, that's true, Kenton. And one of the things you have to really look at these days, we may have talked about it a little bit earlier, is condensate. Because on the newer, more efficient systems, particularly if you see PVC venting like this, where you actually have plastic vent pipe, you have a system that's considerably more efficient than the older systems, and therefore when they get that efficient they have to condense in order to run properly. So there's condensate that has to run out to a drain.
Dave, are there any requirements for minimum slope on these plastic vent pipes?
Yeah, generally a 1/4 inch per foot.
And are there any circumstances under which an inspector should see a trap in the vent pipes?
Every circumstance where it's especially a PVC vented type of system.
Because the gases are cooler, the exhaust gases are cooler?
And there's going to be condensate that develops inside of these pipes, and it has to drain back to the unit, but we don't want it draining into the unit.
Well, I don't see a trap on these. Can you show me where it is?
You don't see one because it's not in the piping. It's underneath here. You see this PVC pipe that comes out and goes down to the drain? That is generally, it needs to be CPVC.
What is this widened section of the condensate pipe?
That's a condensate neutralizer.
So that just makes the condensate less toxic?
Right. Yeah, it
So-
takes out the acidity.
So if you don't see a neutralizer, is the condensate very toxic?
Not terribly. Most municipalities don't require a condensate neutralizer, but some of them do.
Is there a pressure relief valve on this?
Yes, and again, you wouldn't be able to see it because it's behind the cover, but here's the pressure relief valve drain right here.
So we'd be looking for a tube leading down to a drain.
Yep, in the case that you couldn't see it, which would be a case like this.
And depending on where it was mounted, if there were no drain or no drain anywhere close, that's something an inspector should mention.
Yes.
Just because it could damage
Absolutely.
floor materials.
Absolutely.
Dave, what should an inspector see? What components should an inspector see when he's looking at a system like this?
Well, an expansion tank is an important element because the contraction and expansion inside the system, and that avoids any type of accident there.
So water expands into there, not air.
Right. There's a diaphragm in there that allows the water to expand and contract as it moves through the system and creates pressure and reduces pressure. This is what's called a backflow preventer, and that's required on newer installations because the water that's coming in from the system has to have a means to vent versus backing up into the system because we don't want the contaminated water that's in a closed loop to be backing up into the domestic water system.
So that's the vent for the backflow
Yep,
preventer.
and this is something that's missing a lot that inspectors need to look for because there's a lot of talk of problems that are created from closed loop systems backing up into the water supply.
Do they all look just like this one? Pretty much?
Mostly. And then this is a water pressure regulator, also known as a pressure reducing valve. This is a Caleffi system, so the two are combined, but you often will see two separate systems, Watts and Honeywell, and even Caleffi makes some that are separate, where you have the backflow preventer and the water regulator. The water regulator is designed, or the pressure reducing valve is designed to regulate the pressure inside the system. Typical closed loop is under 30 pounds, 30 psi. So you don't want to run a closed loop at much higher than that.
But they'll look pretty similar to what we're looking at right here.
Yep, and the air vent's the other issue, that the other thing that's needed.
If these are in defective conditions, are we looking for corrosion or leakage or anything else?
Corrosion, leakage. You're looking for overpressurization with this. If you can't get the pressure to stabilize, you'd be looking at overpressurization. And there's usually, right here you'll see there's actually a dial that indicates the pressure at which the system is being set.
So that should be at 30 or below?
Generally speaking, yeah.
Okay.
And then the other thing that is important, obviously you have to have a pump. If there's a pump on the system and it doesn't work, then of course all bets are off. You're not going to be able to distribute the heat throughout the building.
So that's the circulation pump?
That's the circulation pump. That's the primary circulation pump. There are also a secondary circulation pump. There is a secondary circulation pump, which is this is a push-pull system, primary and secondary pumps.
So one is in the hot water line and the other is in the cold water return?
Well, it's actually returning the water back to the system, back to the boiler, so it can be reheated and sent back out.
Both of them are in the return?
No, one's on the supply and one's on the return. Generally is how it's set up in this one. Yep, because there's our bypass, and yep, it's set up with one on the supply and one on the return. So one other thing we need to look at is we need to look for a tridicator. And a tridicator, the reason it's called a tridicator is originally it had both temperature, pressure, and atmospheric pressure on there. Now they only have temperature and pressure.
And the temperature should be 180 to 210?
Depends on the system. This system is a radiant floor system, so it's probably designed for 130 or below. And if there's any hardwood floor in this house, then it's probably designed for 96 to 110.
So that's probably not something inspectors are going to confirm?
Nope, it is not. Typically when we find a standard boiler system with radiators or with baseboard, it's going to be 180. But a system like this with radiant floor, no, you're never going to have 180 degrees because it's too hot for the floor. In fact, 71, well, that's probably the temperature of the boiler right now because that's ambient temperature, but I'd be willing to bet that this thing's running at about between 96 and 110.
So Dave, we have water coming from the tankless boiler that's been heated by the boiler coming over into these manifolds. Can you simplify this system for us a little bit?
Yeah, sure. Generally what we see, Kenton, is that the zone valves, which are these, are on the return system. And that's the case here. And in order to find that out, if one were to look at the pump, they'd see an arrow here. And the arrow is pointing in the direction of the flow, and that's how we can tell. It does happen occasionally that the zone valves are on the supply side, but usually they're on the return. And the reason for that is you can shut this zone valve off and open this, isolate the zone valve easily if it needs to be worked on, and shut this so that we can bleed the air out of the system, because that is a typical problem with hydronic systems, getting air in them. It'll cavitate the pump, it'll create noise issues, and the system won't work as efficiently. So they can look at the pump and see which way the direction of the flow is. This is our supply manifold, this is our return manifold, and each one of these zone valves allows the water to come back through into the boiler for each one of these zones that's activated by the thermostat in that area of the house.
So how would an inspector verify that the zone valves are working?
The best way to do it is to go ahead, if they're listed and we know which one of those zones the thermostat it's referencing, is to turn that thermostat on. And what's going to happen then is the zone's going to open up, which means what's going to happen is right now I have resistance, which means this zone is closed. As soon as that we...
What is that?
This is a zone valve.
No, that you pushed.
This is the lever, the lock lever that opens and closes the zone valve manually. There's actually a little servo motor in here. Okay, this motor, when the thermostat calls for heat, this motor will open up and basically automatically open the zone to let the water through. You can also open the zone manually by pushing this over and blocking it. And oftentimes when you're trying to get your flow and see what your flow rates are or whatever you're trying to do, you'd want to do that. What's going to happen is when that zone, that thermostat calls for heat, this thing's going to stay open instead of just, see what happens? It goes back all by itself.
So an inspector who wants to verify whether or not the zone valve is working can do it by turning the thermostat up and checking the temperature of the floor or the baseboard heater in the actual room, in that zone, in the house.
That's correct.
Or they can move the manual lever.
See if there's any resistance against the lever. That's correct.
What kinds of defects would an inspector be looking for in this part of the system?
Obviously leakage. I mean, there's going to be, you got to make sure that there's integrity in the system, that there's no leakage in the pipes. We want to make sure that the zone valve is opening, as we talked about, and usually that's the servo motor is the reason for it not opening. Otherwise, honestly, hydronic systems are pretty fail-safe. There really isn't a lot to go wrong with them.
So this is power for the boiler.
System power, transformer, which fires up the thermostats, which fires up the zone valves. Each one of these zone valves is a pretty good-sized transformer. That's what's needed. These are all 24-volt zone valves, so you do need a pretty good-sized transformer to be able to operate all those zone valves.
So this is a typical setup with the with a power switch and a place to plug in the circulation pump and a transformer. So these are
pretty typical power setup for the power and everything.
And any zone that's on will have the ball valve handles aligned with the pipes.
That's correct.
Dave, without getting into too much detail, are there components on the hot water solar system, the solar thermal system, that an inspector should recognize on each system?
I think basically what they need to be looking at, Kenton, is the fact that we have two pipes generally coming in from the solar panels heating the tank for the solar storage. You're going to have a pump somewhere in the system. Gauges, make sure that the gauges aren't waterlogged, there aren't any problems with maybe gauges not reading what they should, issues with leaks and things like that.
So there are two pipes because it forms a loop. It's a closed system, and so hot fluid from the panels goes through a coil inside the big tank, transfers its heat to water in the tank, and then goes back out to the panels to be reheated.
To be reheated and brought back. It's a constant loop. As long as there's enough heat in the panels, it's going to continue to heat that water. And then the other components would be, you've got a control. The boiler's firing up. How do you like that? And you've got an air relief valve up at the top, and pressure relief, and an expansion tank.
Well, it's a lot simpler now than it was when we first walked in.
Glad to hear it.
Dave, it's been a pleasure. Thanks for being with us.
Thank you, Kenton. Thank you so much.